Is Yellowstone really a supervolcano? The science explained. I don't know about you, but whenever I hear the word volcano, my mind conjures up images of flowing lava, smoke billowing into the air, and dramatic eruptions that cause everything to go black and empty in a matter of seconds. It's hard not to be awestruck by these natural wonders of our planet, but it turns out they can be more complex than meets the eye. One such volcano is Yellowstone National Park in the United States, and it has scientists scratching their heads over whether it's really a supervolcano or not. So what makes a volcano a supervolcano anyway? Well, according to the United States Geological Survey, a supervolcano is defined as a volcano that has had an eruption magnitude of 8 on the Volcanic Explosivity Index or VEI. For context, the largest historical eruption was Mount Pinatubo in the Philippines, which had a VEI rating of 6. Therefore, any volcano with a VEI rating of 7 or higher qualifies as a supervolcano. And this is where Yellowstone gets interesting. You see, scientists have been debating for quite some time now whether Yellowstone qualifies as a supervolcano based on its past behavior. Some argue that its past eruptions were large enough to earn it that title, while others say they weren't quite up to par. Now, we won't spoil the answer for you, but we will take you through the science that helps us understand both sides of the argument. After all, science is never as simple as it seems at first glance, right? So let's get into the nitty-gritty of what makes a volcano erupt in the first place. Picture this. Deep within the Earth's crust, there's a magma chamber. Think of it like a giant cauldron filled with molten rock and gases. As this magma chamber begins to fill, the pressure from the magma pushes against the surrounding rock. If the pressure becomes greater than the strength of the rock, the result is an eruption. Now, different types of rocks have varying strengths, which is why certain magma chambers are more prone to eruptions than others. In fact, the type of rock plays a crucial role in determining a volcano's VEI rating. You see, as magma chambers grow beneath the surface, they don't just expand outwards, they also push the surrounding rock upwards. This upward push forms a dome-like structure known as a volcanic dome. Over time, the shape and composition of this dome influence the way magma flows during an eruption. When the dome is made of viscous or thick lava, the magma tends to stay confined within the dome itself. This creates a buildup of pressure until the rock can't contain it anymore, and when it breaks, the eruption is explosive. On the other hand, if the dome is formed from less viscous lava, the magma has an easier time flowing outwards. In this case, the eruption is much less explosive. Instead, the lava flows more gently down the sides of the volcano. The type of lava also depends on the magma's gas content. The more gas, the more explosive. That's because the gases expand rapidly as the surrounding rock breaks, causing an explosion. Less gas means a gentler flow. Now, understanding these factors helps us grasp how scientists determine a volcano's explosivity index. Now let's focus on Yellowstone National Park. Located in the northwestern part of the United States, Yellowstone is home to the world's largest supervolcano caldera. But hold on, didn't we define a supervolcano earlier? We did. However, the term supervolcano isn't just used to describe a volcano's explosivity, it can also refer to its size, especially when talking about calderas. A caldera is essentially a large basin that forms when the roof of a magma chamber collapses after a major eruption. Now back to Yellowstone. Its massive caldera stretches roughly 43 by 28 miles, which is larger than some entire countries. But here's the twist. While scientists agree that Yellowstone is indeed home to a supervolcano caldera, they can't decide whether the volcano itself should carry that same title. Let me break it down for you. According to the VEI, Yellowstone's most recent eruption in the year 640 had a magnitude of 8. This would officially qualify it as a supervolcano, but wait, there's more. Scientists have discovered evidence suggesting that Yellowstone might have actually experienced 3 eruptions, not just one in the year 640. The first occurred around 2 million years ago, followed by another 1.3 million years ago before the big one in 640. If we consider these 3 eruptions as a single event, then the VEI would change. This is because each eruption added new material to the existing magma chamber. Consequently, the overall eruption column grew taller with each blast, and the amount of ash released into the atmosphere increased. The total amount of ash released during a volcanic eruption is a key factor in determining its VEI rating. Since the 3 eruptions at Yellowstone added up to more ash than if there had only been one, it means that the VEI would be higher. In fact, it would be a 9, making Yellowstone's eruption the largest in history. Now, an eruption of this scale hasn't happened in the last 2 million years. But if the three eruptions are considered together, Yellowstone's eruption would meet the criteria for a supervolcano. But there's still another catch. To make matters even more complicated, scientists don't agree on whether the three eruptions should be counted as one. They're divided into two camps. One group argues that since there were long pauses between the eruptions, they shouldn't be seen as part of the same event. Instead, they should each be individually classified. On the other hand, some researchers believe that since the eruptions were closely spaced geologically speaking, they should be treated as one giant eruption. Each eruption was caused by the same magma source and they collectively had an enormous impact on the environment. To support their view, researchers looked at ice layers trapped in ancient lake sediments. These ice layers act like chapters in a book, separating different periods of time. By dating these layers, scientists can establish timelines for events that occurred during those periods. Using this method, researchers found that the two older eruptions happened so close together in geologic time that they could reasonably be considered a single event. However, the third eruption was more than 3 times as powerful as the first two, releasing more than 4 times as much ash. Despite the similarities in their magma sources, this difference in magnitude raises questions about treating them as a collective eruption. Some argue that the older eruptions were simply a prelude to the main event, setting the stage for the larger eruption that occurred 640 years ago. This view aligns with the idea that the older eruptions were necessary to build up the magma chamber to a critical level for the massive eruption that followed. On the other hand, if the 3 eruptions are not considered a single event, then Yellowstone's rating would drop to a 7. It wouldn't be the largest eruption in history, but it would still be pretty high. What do you think? Should the 3 eruptions be counted as one? Share your thoughts below. Also, if you enjoyed this video, be sure to hit that thumbs up button and subscribe for more engaging science videos. Thank you for watching. Or